set? You're ready?
I think so.
Okay, seid ihr auch Startklar?
Yeah, we're rolling. You can hear me? Yeah.
Hello, hello.
Ich würde euch gleich einzählen, wenn ihr ready seid. Heiko, ready? Okay. Okay, dann starten wir in 3, 2.
Good morning, everyone, and welcome to Homeport. We've got an exciting program for you today. A number of demonstrations in the water and in the air. We're going to kick off the day with the echo.1 team. We have Ollie Anders, who's going to talk us through a demonstration of their surface vehicle. I'm going to hand over to Ollie now, who's going to talk us through how the process works and any other information that he thinks is pertinent.
Hi. Thanks, Louis. So I'm Olli. I'm member of the hydrographic team of the Hamburg Port Authority. We are responsible in the port for all the surveying of the waterways. Hamburg has a big port. We have a lot of water here, and the thing is there's a lot of sedimentation coming in. We have tidal influenced port, which means the water's coming in, bringing a lot of sedimentation, and this sedimentation will bring a lot of difference in the depths of the different parts of the port. That means if ships come in they need clearance depths to have enough water below the keel. And this is not so easy because this changes every day, and we have a lot of vessels to survey. Survey means we go out and have several systems to measure the depths, so from the water to the bottom. And for now 2 years or 1.5 years, we have a new friend. This is echo.1. This is our 5th boat. We have 4 regular survey vessels, diesel-powered big vessels, but we have some areas in the port where we cannot go with our big vessels inside. So we have this new friend here who's very keen to sneak in the small parts of the port and catch every corner which you haven't surveyed before. So this is a surface vehicle. It's not an underwater. It would be not so good if it's underwater. So it's an autonomous surface vehicle. The autonomous part depends on the level of autonomy where we are speaking from. It's an unmanned surface vehicle. Oh, this echo. This means we control it from somewhere else. We don't need to be close. We have different sensors where we can control and steer it. Let's talk a bit about the boat. So obviously it's small. It's 1.65 meters, 70 centimeters width, and has a low draft. This means we can go to shallow areas. Can you have a look at it? It's possible. You cannot clearly see it, but there's a multi-beam. This means from this sensor we can look down to the sea bottom and see what the depths. And then we cruise around with this vessel, and to know where it is, we have a GPS system, GNSS. This means not just GPS, which is from the Americans. We have Baidu, GLONASS, Galileo, the European one. So these 2 antennas give us an exact position. Normally on your mobile phone you have an accuracy of 5 meters maybe. Here we have corrected data and this means we have an accuracy of a few centimeters. So 2 centimeters is fine for us, is fine for the survey, and this is quite good accuracy. Furthermore, to communicate with the vessel, we have different antennas. We have our first solution is a Wi-Fi. It's a Wi-Fi antenna. So with this Wi-Fi, we can communicate directly to the control center, which is over here. The control center is a notebook. The next one is a backup. This is a mobile connection in LTE or 4G at the moment. In Hamburg, we start to build up the 5G network. This will be the next one integrated, which has a much lower latency. And at the moment, here from the booth, we have no cable, no Wi-Fi, because this is a demonstrator. We have one boat in the water, and we will communicate over cell phone communication. So now we launch the boat. This means we can have a look at the water and see if it's still swimming. I will come over here. So maybe we can have a look at the water if the drone is in. I don't see anything. So, if you have a look at my screen, we have 2 cameras which I see as a control guy. This is one directly from the vessel. A front view, I can steer the camera. It's a pan, zoom, tilt camera. I have here on the upper right corner, I see the status of the boat, like battery status, position status, heading, all this technical stuff. And for the survey part, on the left screen, we see all the measurements which come when we start. So we see the vessel is in the middle of the Fair Canal, which is now about 500 meters from our side. So we are standing maybe here. I don't see anything from the boat right now. I just see here what is shown on my screen. So I would say we just start our first survey. And I just easily say the boat where to go. I just asked if everything is clear from the water side. Ist alles frei? Danke Dann gib mir bitte die Kontrolle und kannst auf Auto setzen. So the mission is now sent to the boat, which means the boat will transit to the first control point. And what we will see on the screen is the real life depth measurement of the boat, which is transferred to the software. On the right, there's a color scale, so all the depth measurements are shown in different colors. The boat follows its line. This is done fully by itself by the boat. It's an electrical powered. We have 2 batteries. We can go up to 6 knots, a normal survey speed.
I was wondering, so how long, what length of missions can this run if it's electrical powered?
Oh, the boat is built for a working day. This means we have 2 batteries which last about 6 hours. So we can run for about 6 hours without recharging or coming back to the mother vessel or to shore.
And then what does that translate to in terms of area? I guess it depends on the sort of conditions, but generally?
I cannot say in square kilometers, but it's enough to have a quite big area surveyed in 6 hours.
Okay, great.
So compared to a normal vessel, it's similar. What we want to do with this boat is to use it as a second boat. So our plan is to have a mother vessel, like the normal vessel, normal survey vessel, and then this small one launched on the back deck. If you come to an area, you just hook it on the crane in the back, lower it to the water, and then have it as a force multiplier. So the normal survey vessel is doing its job, and this small one is doing one line, and maybe if you get another one, a second one, and we have a fleet of boats surveying and can do much more in the same time.
Okay, so it's never seen as a replacement for a manned vessel entirely. It's always in tandem with a manned vessel and then sort of gets deployed as a fleet.
Especially the small ones are nice and handy to handle. As long as they are small and handy, we can just deploy it and have it as a second edition. If they get bigger, they need more personnel, need more organization, much more logistics to get it in the water and to start the job. So, yeah, a big boat could be replaced, but you need the same personnel as before, maybe more, because to handle it. So, these ones won't replace any big vessel at the moment, but yeah, in the small areas like confined areas or small parts, we can go within another vessel. We just throw it in the water. But this throwing in the water is not that easy, because if you have a key wall, and so this is 60 kilograms, you need an option to bring it in the water. So that's why on the other cranes we have, on the other vessels we have a small crane to launch it from the mothership. So kannst mal auf Auto gehen? Point.
And then just linked to that control question, so in terms of this deployment from another boat, do you envisage that this control center would be on the boat or it would be onshore?
So technical, it can be anywhere. But it's easier for the guy who's controlling it to have a clear view. That's obviously you don't need it.
Please take it this here. This is the antenna. No, thank you.
You don't need to be in the same area. You can sit anywhere in the world, of course, but it's always easier to have to be in touch with the vessel, to talk to the persons which are helping you. But yeah, like right now, we are not close to the vessel, so it's possible. So what I showed you now is the depth measurement. The deeper parts are here in green, and if it's going shallower, it's more red. But we had a new LiDAR scanner. This is a laser scanner which we mounted on top of the vessel. So what we just surveyed is the depths, so below the water. What we can also do is in the same moment scanning all the surroundings. So what we see here, is, or what you can imagine are all the trees and the surroundings above water. What we use it for is to have a better overview of the area, because I don't know if there are other vessels. The vessels are moving, they are not stationary. We have the automatic identification system, which shows us where other vessels are. But if they are moored and this identification system is off, I need to scan the vessel itself, and that's what we can do with the laser scanner on top.
Okay, so it's more as a safety feature.
It's a safety feature. It could be used in the future for autonomous route calculation, which is not implemented in the software yet. But of course, if we scan an object, we could deter the route and try to navigate around it. So what I said in the beginning, the autonomy level is we have a radar, so we can detect the distance to other objects. But what to do with the information is more or less now on my side. So the vessel gives me the information, okay, there's an object, it's 30 meters away, it's in my course, and it will give me the information there is an object. So the going around and calculating a new route is what is not implemented yet, but where the evolution of collision avoidance systems will go in that direction.
Okay, so it can be, so other collision avoidance systems can easily be overlaid on the existing software as well. So it progressively should improve as the technology does as well.
Yes, we need the software to implement the AIS system, so the automatic information system from the other vessels, overlaid with the radar. The radar from our vessel, maybe the information of the radar available from the nautical traffic center, which they could send us. Then the information, the standard information we have from the nautical chart. Yeah, and that should be combined in a so-called heat map where you can deter our route. And that's why we as a port organization, so we use this system right now as not as a demo, we use it in real life. Not every day, but we need to keep our hand on the boat to know what are the systems, what other manufacturers can do. And if they come to our port and say, hey, we have the best autonomous boat, which has a quite good collision avoidance or something, we know what is capable at the moment with the actual state of the software and what we can expect from such an autonomous vessel, and where we need to have more programming and whatever to do.
So that's an interesting point, and obviously I see Hamburg Port Authority written on your jacket, and it's the echo.1 sort of hardware. So I'm just wondering, how did that process work? I mean, where did the hardware come from? How did it get approved? How did it then come to the Hamburg Port Authority?
Oh, we had a big workshop when this, you see it everywhere these autonomous vessels arise. And we as a port organization see that, and we want to keep in touch. We want to know what is happening on the market. So we organized a big demonstration or demo workshop with several suppliers. This was 3 years ago now, with bigger vessels, smaller vessels. We invited them all to Hamburg, and they did their demonstrations. So we had not our own vessel before, and we saw what was possible. And the big logistic thing with the Oberhafenamt, it's called, so the authorities in Hamburg. We said we want to do a demonstration, give it just an area where they can cruise around. And they said, whoa, what are these vessels doing? So all the regulatory stuff, this needs to be handled as well. And all this can be much more easily done with a boat which we have in the port, and we can test it. We can show it to the authorities and say, hey, we need this regulation and this. And that's a progress which is now finished. We have regulations for other vessels as well at the moment. So if anybody else comes with its boat, we have a setup or a list what needs to be done, which regulations need to be fulfilled. And this is, I guess, the first port in Hamburg where you can come with your autonomous vessel, maybe here through the home port area, and bring the vessel in the water, and we have these regulations already tested.
Okay, so what you're saying is, by bringing the technology in-house to start with, it kind of allowed the Port Authority to work through the regulatory issues that they might have, they're going to foresee down the line, use it kind of as a test, build out the regulatory rule book, and then now with Home Port trying to test new technologies, when an autonomous surface vehicle comes in, they say, okay, we've done it with echo.1.
Yes, so it was very interesting in the beginning to have this small vessel, which is more or less hand-controlled. It gives us information on this autonomy information. But now the next step is to have this automatic collision avoidance, and there will be other companies and guys coming which say, we have just this piece of software, please test it. They don't have any boat, they have no crews, they have no anything. They just come with a software which we can maybe just implement and test it, and then say to the authorities, okay, this is fine, this is working, and we can publish it to other, maybe as a certification or a label where we can say, hey, this is fine, this software works as a collision avoidance system, and we can use it.
Okay, great. And actually on the collision avoidance, I mean, I personally have worked more in the unmanned airspace area, where obviously a collision with a small drone, with an airplane, into an airplane engine or into a helicopter could be disastrous. Now, to me, this doesn't look like a massive vehicle compared to the size of the ships that are coming into the port. So, I mean, obviously it's an issue, but is the main concern for this vehicle, or is there actually a genuine danger?
If you're sitting on the container vessel, you obviously don't see anything of the boat itself. It's just a small, tiny piece in the water. It could be a bird as well or whatever. But on the screen, on the container vessel, he has this radar and this automatic identification system. And for the pilot on the container vessel, he just looks on the screen and sees, oh, there's a vessel. Okay, it's 1.65 meters, but he could read it as 100 65 meters. So he sees this boat and will automatically recognize it and talk to the via VHF, via radio to it, and say, hey, there's a boat, you need to keep clear. So he won't say, oh, it's a small vessel, I just go over it.
All right, so it's protecting the hardware and obviously just making sure that people aren't going over it day to day.
So if the container vessel will stop, it's not possible for us. So you need to have all these regularities with a small vessel as well as the big ones. It doesn't matter. The size doesn't matter here.
Sure. And has the mission finished now, or I can see it's still going?
The mission is more or less finished, but we can say to you guys in the container, they can show us the video of the cloud compare demo, which maybe they can show on the screen.
Sure, is that possible? I don't know who we're talking to right now. Can anybody see the screen in terms of, is there being shown?
Yeah.
We're wondering,
Yeah, it's
the demo, we can't see what's being shown on here, so we're wondering if the demo.
So on the stream, I see in a bigger scale what we did here on the small screen. The final result of a bigger measurement. So all the depths, which is then loaded in our database to the office and can be published to any customer in-house or to the pilots, to external clients.
And can you tell us, Ollie, how often does this need to be done for a port like Hamburg? I mean, is it a constant process, dredging, redredging the river?
It's a circle. So on our daily business at the hydrographic department, we have 4 vessels, 4 regulatory vessels, which are surveying 5 days a week, every day. And this small one is just an addition, which will help us to do more.
Okay, so based on the sheer size of the port, it's just a case that you've constantly got to be measuring and then redredging as...
We don't dredge at much deeper than we need to. It's a certain depth level, and this needs to be controlled more or less every week. If special bigger ships come, which are highly loaded, they need a pre-survey just before the vessel comes. So the turnaround time between surveying and the data published to the public is for 2 hours. So we do our survey, finish the survey, which may last maybe 4 hours, upload the data to the office. There's a cleaning process, which is done from the in-house guys, and then it's directly pushed to our database servers, where then at the moment accessible via all of the client. And this is from finished survey to the client, could be 2 hours.
Okay, and could you foresee in the future ever, I mean, at the moment this is a service or hardware that is linked to the Port Authority. Could you ever foresee this actually being a piece of equipment on ships more generally that then they could deploy as they're going into sort of unknown waters or areas that they're not unsure of?
I guess so. There needs to be an authority which has the equipment and the trained personnel and certified equipment. So you cannot just do your own survey on another vessel, launch your own survey vessel and do a depth measurement. You need to be sure that it's right, and that's what we guarantee as an authority.
Okay.
And I have another demo, another video, which is called Megaswas, which shows the survey of two vessels. So we have a mother vessel, and then this one deployed alongside the big one, and they're doing a combined survey with two vessels. Maybe we can show it on the screen as well.
Do you guys know if that's being shown? I mean, if that video was being shown, what would it be showing us?
It would be showing us the mother vessel, and then our echo.1 deployed in 10-meter parallel and doing a combined survey. That's what I said in the beginning, it's a force multiplier. One vessel, one crew, but an additional sensor vessel, depth measurement vessel, doing the same work, but have the same personnel on board.
And then at the moment, as a team, how big are you, and how many of these echo.1s do you have?
Our team at the Hamburg Port Authority is 25 people. So we have processing guys and offshore, no, offshore is not, the survey guys on the vessel. So we have 4 vessels, whereas mainly one surveyor. And I would say for 1 hour surveying, we need 2 hours in the office to process it.
And then in terms of setting up the sort of the mission of, so for example, the one that you did today, is it very straightforward? It's super quick and then just set it off, or is there other sort of preparation work that needs to be done?
It takes a bit time to have your routine to set this up. At the moment, we have not a fixed mother vessel where everything is installed. We move the equipment with the boat, and the boat is sometimes in a smaller area, sometimes launched from the bigger vessel. So this is not all fixed and the routine. We need to plan the mission. There are, I would say, 2 guys which plan it in the morning. So we have a nice area where we can survey with Echo. We take it with us and do additional survey alongside the other vessel which is doing its own survey. But yeah, in the future it will be more streamlined. So it's no big issue to have this little guy here with us.
And what maybe hardware upgrades or sensor upgrades could you foresee coming in the future? Is there a particular area you want to improve upon or extend its capabilities?
At the moment, we are limited with the payload on the vessel. So the small vessel has a specific payload, and this is at the moment our maximum which we can mount on it. So the multi-beam echo sounder, which is at the bottom, is heavy. The PC inside is heavy, and we upgraded the LiDAR system, a laser scanner on top of the one which is surveying in the canal at the moment. So this is the maximum payload we can take. We have a moon pool where we can interchange systems. We can dismount the multi-beam and add an acoustic Doppler velocity profiler which can measure current. So the current, this we can interchange. So the next step would be a bigger vessel where we have more payload.
Does that have any implications for the regulations? Like, is this only approved at its current size, or is it maybe a streamlined process if it was, say, to double in size?
I guess we will have, with a bigger vessel, the regulations stuff is going easier because we will have more sensors. We have a much better situation awareness, better look around, and then we will convince the authorities more easily what is capable with these kind of boats.
Okay, thank you. Is there anything else in terms of the mission that you'd like to talk us through, or?
I guess not. Any questions from?
Any questions? No? Cool. I think in that case we will wrap this up for now. You're presenting again on, I think it's Thursday morning. Is that right?
On Wednesday we are at 1300.
Okay, every day, actually. So
Every
there'll
day.
be a chance to catch this again. We'll wrap this up for now. I think next up we have maybe RoboVas giving a short demo of their robot in the water, and I think that will be live streamed as well. So thank you very much.
Thanks, Louis.
Thanks, Ollie.
As the world becomes increasingly digitalized, so are ports and maritime transport. Sensor data collection is increasing safety and security measures and operational efficiency, whilst technologies will continue to reduce accidents, economic costs, and carbon emissions. The Robotic Vessels as a Service, aka RoboVas project, is about demonstrating services that connect cloud-based software infrastructure, a fleet of autonomous vehicles, and innovative sensor and inspection technologies to show the potential of on-demand maritime robotic services for larger-scale deployment. When a user requests a service via the RoboVas cloud, autonomous surface vehicles, ASV, are deployed to collect data for the given service that is relayed back to the cloud. Possible users include ship captains for anti-grounding, ship owners for hull inspection, port authorities for key wall inspections, or terminal owners for data collection. The RoboVas demos include 5 services that provide data to the users. Ship hull inspections using the remotely operated vehicle, ROV, launched from the ASV, can inspect and locate possible damages precisely without any risking diving operations. Key wall inspections can be performed by both ASV and ROV as routine inspections with high detail sensors, thus reducing the operational costs dramatically. Data muling relies on underwater acoustic communication to transmit data, which is useful in port areas where buoys or tethers can be obstacles to vessels. Bathymetry data collection uses ASV to map depth deviation from nautical charts, allowing for up-to-date information in areas with high tidal variation. Anti-grounding has an ASV traveling ahead of a vessel and collecting depth data in real time. Depth deviation from nautical charts are communicated to the merchant vessel immediately, improving safe passage in critical areas. The RoboVas project provides proof of concept for improving the operational flexibility of systems with unmanned underwater and surface vehicles, as well as cutting-edge sensor imagery. However, the human dimension will remain necessary, particularly for more distant operations and for safety precautions. The future system includes upgraded vehicles with improved autonomy, better underwater inspection sensor technology, and a completely new field of aerial inspection with ASV drone integration. The The robust data cloud network is a solid foundation to build upon for future developments. RoboVAS is a solution for on-demand shipping services and near-shore operations for all ports, offering easy accessibility to European waters and enhancing maritime transport. RoboVAS is the future of maritime port operations. As the world becomes increasingly digitalized, so are ports and maritime transport. Sensor data collection is increasing safety and security measures and operational efficiency, whilst technologies will continue to reduce accidents, economic costs, and carbon emissions. The Robotic Vessels as a Service, aka RoboVAS project, is about demonstrating services that connect cloud-based software infrastructure, a fleet of autonomous vehicles, and innovative sensor and inspection technologies to show the potential of on-demand maritime robotic services for larger-scale deployment. When a user requests a service via the RoboVAS cloud, autonomous surface vehicles, ASV, are deployed to collect data for the given service that is relayed back to the cloud. Possible users include ship captains for anti-grounding, ship owners for hull inspection, port authorities for key wall inspections, or terminal owners for data collection. The RoboVAS demos include 5 services that provide data to the users. Ship hull inspections using the remotely operated vehicle, ROV, launched from the ASV, can inspect and locate possible damages precisely without any risking diving operations. Key wall inspections can be performed by both ASV and ROV as routine inspections with high detail sensors, thus reducing the operational costs dramatically. Data muling relies on underwater acoustic communication to transmit data, which is useful in port areas where buoys or tethers can be obstacles to vessels. Bathymetry data collection uses ASV to map depth deviation from nautical charts, allowing for up-to-date information in areas with high tidal variation. Anti-grounding has an ASV travelling ahead of a vessel and collecting depth data in real time. Depth deviation from nautical charts are communicated to the merchant vessel immediately, improving safe passage in critical areas. The RoboVAS project provides proof of concept for improving the operational flexibility of systems with unmanned underwater and surface vehicles, as well as cutting-edge sensor imagery. However, the human dimension will remain necessary, particularly for more distant operations and for safety precautions. The future system includes upgraded vehicles with improved autonomy, better underwater inspection sensor technology, and a completely new field of aerial inspection with ASV drone integration. The RoboVAS data cloud network is a solid foundation to build upon for future developments. RoboVAS is a solution for on-demand shipping services and near-shore operations for all ports, offering easy accessibility to European waters and enhancing maritime transport. RoboVAS is the future of maritime port operations. As the world becomes increasingly digitalized, so are ports and maritime transport. Sensor data collection is increasing safety and security measures and operational efficiency, whilst technologies will continue to reduce accidents, economic costs, and carbon emissions. The Robotic Vessels as a Service, aka RoboVAS project, is about demonstrating services that connect cloud-based software infrastructure, a fleet of autonomous vehicles, and innovative sensor and inspection technologies to show the potential of on-demand maritime robotic services for larger-scale deployment. When a user requests a service via the RoboVAS cloud, autonomous surface vehicles, ASV, are deployed to collect data for the given service that is relayed back to the cloud. Possible users include ship captains for anti-grounding, ship owners for hull inspection, port authorities for key wall inspections, or terminal owners for data collection. The RoboVAS demos include 5 services that provide data to the users. Ship hull inspections using the remotely operated vehicle, ROV, launched from the ASV, can inspect and locate possible damages precisely without any risking diving operations. Key wall inspections can be performed by both ASV and ROV as routine inspections with high detail sensors, thus reducing the operational costs dramatically. Data muling relies on underwater acoustic communication to transmit data, which is useful in port areas where buoys or tethers can be obstacles to vessels. Bathymetry data collection uses ASV to map depth deviation from nautical charts, allowing for up-to-date information in areas with high tidal variation. Anti-grounding has an ASV travelling ahead of a vessel and collecting depth data in real time. Depth deviation from nautical charts are communicated to the merchant vessel immediately, improving safe passage in critical areas. The RoboVAS project provides proof of concept for improving the operational flexibility of systems with unmanned underwater and surface vehicles, as well as cutting-edge sensor imagery. However, the human dimension will remain necessary, particularly for more distant operations and for safety precautions. The future system includes upgraded vehicles with improved autonomy, better underwater inspection sensor technology, and a completely new field of aerial inspection with ASV drone integration. The RoboVAS data cloud network is a solid foundation to build upon for future developments. RoboVAS is a solution for on-demand shipping services and near-shore operations for all ports, offering easy accessibility to European waters and enhancing maritime transport. RoboVAS is the future of maritime port operations. As the world becomes increasingly digitalized, so are ports and maritime transport. Sensor data collection is increasing safety and security measures and operational efficiency, whilst technologies will continue to reduce accidents, economic costs, and carbon emissions. The Robotic Vessels as a Service, aka RoboVAS project, is about demonstrating services that connect cloud-based software infrastructure, a fleet of autonomous vehicles, and innovative sensor and inspection technologies to show the potential of on-demand maritime robotic services for larger-scale deployment. When a user requests a service via the RoboVAS cloud, autonomous surface vehicles, ASV, are deployed to collect data for the given service that is relayed back to the cloud. Possible users include ship captains for anti-grounding, ship owners for hull inspection, port authorities for key wall inspections, or terminal owners for data collection. The RoboVAS demos include 5 services that provide data to the users. Ship hull inspections using the remotely operated vehicle, ROV, launched from the ASV, can inspect and locate possible damages precisely without any risking diving operations. Key Key wall inspections can be performed by both ASV and ROV as routine inspections with high detail sensors, thus reducing the operational costs dramatically. Data muling relies on underwater acoustic communication to transmit data, which is useful in port areas where buoys or tethers can be obstacles to vessels. Bathymetry data collection uses ASV to map depth deviation from nautical charts, allowing for up-to-date information in areas with high tidal variation.
Yeah, hello, good morning from myself. My name is Vincent Schneider. I'm the project coordinator for the project RoboVas, and we want to give you a short demonstration here, introduction into the project, and then we show you our ASV Sea Lion as a live demonstration. So maybe we go down here, how it all started. So within the project RoboVas, one core feature are our ASV, our autonomous surface vehicles. And the first one that we developed, you see here. We developed this within the 3-year project with 7 partners from 3 nations. And once we had developed that one, we found out that we wanted to develop another one to have more flexibility and even show more what the project can do. So we developed the second one, Sea Lion, that you see up here. And this one you will see also today in a moment. But maybe I can quickly say something about RoboVas and what we do. So the idea was that we develop services based on robotic vessels, and we use these as a service. So the 5 services that we developed are an anti-grounding service, which has been tested in full-scale simulation, and then 2 inspection services, key wall inspection service and ship hull inspection services, and bathymetry data collection and data muling. And right now we can go a bit into detail about the key wall and ship hull inspection services, which rely on state-of-the-art sensor technology, and there my colleague Alex will tell something about it.
Yeah, thank you very much. My name is Alexander Duda. I'm co-founder of Kraken Robotics in Germany and key leader of, or technical lead of Sea Vision. I'm going to talk a little bit about now in the next minutes. So we have here an underwater structured light system that use 6 lasers that are steered over the scene to get 3D reconstruction in sub-millimeter resolution. You can see a result of our tests on the screen. And so the plan is to, or our vision is to put that on an autonomous vehicle that is going along the ship hull or the pier, and you call that on demand as a service similar you would do with a cab, for example. Yeah.
Okay, thanks, Alex. And now we can go over to the Sea Lion, actually, which is down here in the port. And we can start a live demonstration there of how we deploy a ROV, a remotely operated vehicle, from such a vehicle, and can do an inspection service. So if we now switch to the water view. Okay, there you see our Sea Lion in action. That's down here in the port of the home port from the HPA. And we will show you how such an inspection service can work out. So the Sea Lion can now move with up to 8 knots to the inspection site and is carrying the small blue rov, the blue robot you see on the back there. And we approach the key wall that needs inspection. Once the key wall is reached, the vehicle can position itself and then enters loiter mode. So that means that we hold position with the ASV and the deployment of the ROV can start. So therefore we use our last system that we developed within the project. So we have a winch there on the front of the vehicle and an A-frame at the back. And any minute now the ROV will be lifted up You can see that now. Once we reach the highest position, the A-frame will open and we can lower the RV in the water to start inspection. So the system that we developed here is capable of lifting up to 30 kilos of payload in the air. Our blue ROV that we're using is only 11 kilos, so we have quite some room there to deploy any payload that you might want to deploy or we will deploy in future projects. Once the A-frame is completely extended, that should be any second now, we can start the lowering of the blue ROV, and then the inspection can start. The C-Line is actually a modular test platform that we developed. So the A-frame and the winch, as part of the LAS, we can actually remove and then put any payload on there that we want. And the maximum payload limit is 120 kilograms. So now you see that the RV is in the water. We would love to show you how the view in the water looks like, but unfortunately, we only have 20 centimeters of visibility in the port of Hamburg, so the picture would not be very interesting, we can say. So when we imagine that the inspection now is finished, we will recover the ROV any minute. And the overall distance between C-Line and ROV can be up to 50 meters. So we have a 50-meter tether cable in here, which is for the environment that we want to use the system in, the port environment, more than enough. For example, the water depth in Hamburg is not even twice that. And the C-Line can also reposition itself so that we do not extend the maximum cable length. So now you can see how the blue ROV is lifted out of the water again. This process is completely autonomous. And once the vehicle is lifted up, we fold in the A-frame again, and then the vehicle is safely stored on deck again. So that ends a complete successful inspection, and now the C-Line can go to the next inspection site or to its home port and recharge the batteries, for example. It's a completely battery-driven system that we have developed here with a top speed of 8 knots, and if we cruise at 6 knots, we have 24 hours of mission endurance and can therefore cover more than 260 kilometers. Yeah, and that's it for today, for our demonstration, how a RoboVAS service can look like. And I thank you for your attention. And thank you for your attention.
As the world becomes increasingly digitalized, so are ports and maritime transport. Sensor data collection is increasing safety and security measures and operational efficiency, whilst technologies will continue to reduce accidents, economic costs, and carbon emissions. The Robotic Vessels as a Service, aka RoboVAS project, is about demonstrating services that connect cloud-based software infrastructure, a fleet of autonomous vehicles, and innovative sensor and inspection technologies to show the potential of on-demand maritime robotic services for larger-scale deployment. When a user requests a service via the RoboVAS cloud, autonomous surface vehicles, ASV, are deployed to collect data for the given service that is relayed back to the cloud. Possible users include ship captains for anti-grounding, ship owners for hull inspection, port authorities for key wall inspections, or terminal owners for data collection. The RoboVAS demos include 5 services that provide data to the users. Ship hull inspections using the remotely operated vehicle, ROV, launched from the ASV, can inspect and locate possible damages precisely without any risking diving operations. Key wall inspections can be performed by both ASV and ROV as routine inspections with high detail sensors, thus reducing the operational costs dramatically. Data muling relies on underwater acoustic communication to transmit data, which is useful in port areas where buoys or tethers can be obstacles to vessels. Bathymetry data collection uses ASV to map depth deviation from nautical charts, allowing for up-to-date information in areas with high tidal variation. Anti-grounding has an ASV traveling ahead of a vessel and collecting depth data in real time. Depth deviation from nautical charts are communicated to the merchant vessel immediately, improving safe passage in critical areas. The RoboVAS project provides proof of concept for improving the operational flexibility of systems with unmanned underwater and surface vehicles, as well as cutting-edge sensor imagery. However, the human dimension will remain necessary, particularly for more distant operations and for safety precautions. The future system includes upgraded vehicles with improved autonomy, better underwater inspection sensor technology, and a completely new field of aerial inspection with ASV drone integration. The RoboVAS Data Cloud Network is a solid foundation to build upon for future developments. RoboVAS is a solution for on-demand shipping services and near-shore operations for all ports, offering easy accessibility to European waters and enhancing maritime transport. RoboVAS is the future of maritime port operations.